Hello and welcome to Year 7 energy lesson, and this one's on non-renewable energy resources. My name's Mr. Pratt, I'm Director of Science. So before we start, for the lesson you're going to need a pen, paper or an exercise book, and unless you're having to view this video on your mobile phone, put it on mute, or better still, switch it off. Try and avoid all the distractions that you can. So straight into the starter then, let's see what you can recall from previous lessons. So I want 3 energy stores, 2 energy transfers, and the unit of power. 2 minutes. Okay, you should be pretty much finished off. Don't forget, what is the unit of power? What is the unit of power? Okay, there's quite a few energy stores that you could have had, and the list is going to come up later in the lesson, so you might have had something that I don't say. So gravitational potential energy, kinetic energy, nuclear energy, thermal energy, elastic potential energy, chemical energy, might have said that one. So there's quite a few there. Now the transfers, there's only 4. So the transfers, you could have had thermal again. Thermal energy is both a transfer and a store. You could have had light or sound, electromagnetic. And what is the unit of power? Answers in the question. What is the unit of power? W-A-T-T. So if something's got a power of 10 watts, it means that it uses 10 joules of energy every second. So outcomes. We're going to describe the difference between renewable and non-renewable energy resources and explain where the energy in non-renewable sources has come from and how we release it. So energy resources. So these are the things that we use in the modern world to generate electricity, power your mobile phones. All of those things have required an energy resource to be used in the first place. So we can divide energy resources into 2 types. We can have renewable energy resources and non-renewable energy resources. So I want you to think what that word renewable could mean. And to help you with that, if I've got 2 examples of energy resources, so coal and solar power are both energy resources. One of them's renewable and one of them's renewable. Which one do you think is which? Okay, so solar power we'd say is renewable, and coal we'd say is non-renewable. So a non-renewable energy resource like coal is one that we use up quicker than it can be replaced. So coal is taking a very, very long time to form under the ground, and we'll explain later in the lesson how it does form. So it takes so long to form that when we use it, we're using it much more quickly than it formed. So therefore we are going to run out of it. We can't easily replace it. Renewable. So these ones can be replaced as quickly or even faster than it's used up. So one example would be solar power. Now we don't actually use solar power up, so we're not going to run out of it. We say it's easily replaced. So if an energy resource can easily be replaced, we say it's renewable. So if you've got that, if you've got an understanding of renewable and non-renewable, you should be able to make a good go at splitting this list of energy resources into renewable and non-renewable. You can either write them in two columns, or you can just put an R and an NR next to them. I'll give you 2 minutes. Halfway. There's one more in the renewable column than the non-renewable column, if you want to give yours a check. Right, so I'll show you the answers if you give yourself a mark out of 9. There's a couple that are tricky. I reckon you should have got maybe 6. That'd be pretty good. So solar, biomass, I'll explain to you if you're not sure what that is in a second. Wind, hydroelectricity and geothermal are all renewable, so they're easily replaceable. Coal, crude oil, natural gas and nuclear, that might have been one that you struggled with, are all non-renewable. So you might have heard of hydrogen, particularly hydrogen fuel cells, being used as an energy resource for cars instead of petrol or diesel. Do you think that would be renewable or non-renewable? Okay, so it'd be it will be renewable, sorry. So that's a big advantage if we can power cars, because petrol and diesel are coming from crude oil, so they're non-renewable, so they're not easily replaceable. So I've got a video for you now, and at the end of it you're going to describe how fossil fuels are formed.
Fossil fuels. Fossil fuel is a term used to describe a group of energy sources that were formed from ancient plants and organisms during the Carboniferous period approximately 360 to 286 million years ago, even before the age of dinosaurs. At that time, the land was covered with swamps filled with organisms and plants. As they died, they sank to the bottom of swamps and oceans and over millions of years started decomposing under layers of sand, clay, and other minerals. Different types of fossil fuels formed depending on the combination of organic matter, temperature, time, and pressure conditions while decomposing. There are three major types of fossil fuels: coal, oil, and natural gas. Coal was formed from ferns, plants, and trees, which hardened due to pressure and heat. Oil was formed from small organisms like zooplankton and algae, where pressure caused the more complex organic matter to decompose. Natural gas was formed by the same process as oil, only it was exposed to more heat and pressure, causing it to further decompose and turn into a gaseous form. Fossil fuels are sought-after energy sources because they have a high energy density. They are the world's dominant energy source. Fossil fuels have a variety of applications from electricity production to transport fuels. They can also be used to make a variety of common products, from plastics to cosmetics to even some medicines. These resources have powered industrialization over history and continue to do so today. Fossil fuels can be an abundant and cheap, or in some cases, a scarce and expensive form of energy, depending on geographic location. For this reason, geopolitical issues arise due to scarcity caused by the natural geographic allocation of these highly valuable resources. Fossil fuels are considered non-renewable resources because they take millions of years to form, which means that once they are used, the resources will not be replenished in a human lifetime. The gradual depletion of the most accessible fossil fuel reserves have forced companies to develop technologies for extracting more challenging or unconventional reserves. In many cases, this means additional safety and environmental concerns as well as higher costs. Fossil fuels are also the largest emitters of carbon dioxide, a greenhouse gas which causes climate change. In addition, their production causes both environmental and human health issues. These concerns have triggered society to look at alternate sources of energy that are more environmentally sustainable and renewable. That's fossil fuels.
Okay, from that video then, I wanted you to describe how fossil fuels are formed, and are fossil fuels renewable or non-renewable? Explain. 2 minutes. Okay, a minute left. So this diagram here has got coal on, but there's not much difference between the way that they form coal, oil or gas. So we're talking 300-ish million years ago, living things, animals, plants, are dying, particularly in the swamps, and then they're covered over with water and dirt, so they become decompressed underneath. And then as they get deeper and deeper, they get more and more heat and pressure, which can turn those dead plants into coal. You'll then get coal, oil and gas forming deep underground, and this whole process takes millions of years. So if it's taking millions of years, all fossil fuels are non-renewable because we can't easily replace them. We use them much more quickly than they can form. So we've got a flow diagram here, starting with the sun and ending up with electricity being generated at a power station. And I want you to look and describe how the energy stores have changed at each step. So what is the energy store that we're starting with, and what's happening to the energy at the end? Now, I'll give you 2 minutes, but halfway through the 2 minutes, because some of you might have forgotten, I'm just going to flip up a little bit of help that's got a list of all the energy stores on from a previous lesson. Okay, there's a bit of help there. Okay. Okay, so I've just changed the pictures into a list, 1 to 5. So number 1, stored in the sun. So the sun is storing energy in the form of a nuclear energy store. And then that is converted by the plants by photosynthesis to chemical energy store. Now you'll notice I've not mentioned light there. Light is the way that the energy is transferred, so it's not an energy store. So energy is transferred by light, which is electromagnetic radiation from the sun to the earth, but that's not an energy store. So then we've got next stored in plants. So the animals then are eating the plants. So then you'll have a chemical energy store in the animals. Then the animals die, get buried deep underground, and the energy is stored in the fossil fuel. And again, that's stored as chemical energy. Then we burn the coal, and as we burn the coal, we get kinetic energy, which is the turbine, the way that you get the energy from the steam, turning a turbine that can then turn a generator. This links into electricity lessons later on. And then that's transferred as electrical. So we've got a transfer there is electrical, so that's not an energy store. And then that goes out to houses, factories, etc. all over the country. And fossil fuels have been incredibly important over the last 300 years. Britain's had a very large reserve, particularly of coal, and it's used it to generate a lot of energy that's powered the country. They're very reliable resources. They're not dependent on the weather. So if you've got a load of coal, you know you can burn it and produce energy from it, and it's there day in, day out, reliable. They also have what's called a high energy density. So if you have a certain amount of it, you've got a lot of energy stored inside it. So you've got lots of stored chemical energy inside. So let's now look at the disadvantages of using fossil fuels. So I've got this paragraph here. I'm going to read it for you as well. But as we read through it, I'm looking for 3 disadvantages that we could put as 3 very short sentences. Fossil fuels took millions of years to form in the Earth's crust and can never be replaced once they've been used. If we keep using these fuels, they'll eventually run out. We call fuels that will run out non-renewable. Oil and gas will be the first to run out, and then coal. When fossil fuels burn, they release carbon dioxide into the atmosphere. Research shows that a major contributor to the greenhouse effect and global warming is our overuse and burning of fossil fuels. Coal and gas also release sulfur dioxide gas when they're burned. Sulfur dioxide can cause breathing problems for living creatures and also is a major part of acid rain. Okay, should just be finishing off. Right then. So, fossil fuels can't be replaced once they run out. You could actually put one disadvantage is that they're non-renewable, but if we explain what that means, so we can't replace them once we've run out. Next one, greenhouse effect. So when you burn fossil fuels, you get carbon dioxide released, and that causes the greenhouse effect, and that's the effect where more heat is trapped in the Earth's atmosphere. So it's causing global warming is the second disadvantage, or it's one cause of global warming. And the last one is pollution. Coal and gas, actually, and oil as well, to be honest. Gas produces the least of all 3. Releases sulfur dioxide when you burn it, so that causes acid rain. It can cause asthma as well in highly polluted areas, so it's a major cause of acid rain. So it's the pollution that it causes when it's burnt is the third disadvantage. So plenary then, 3 bits for you to do. Why are coal, crude oil and natural gas considered non-renewable? What about uranium? That's a nuclear fuel. Is it renewable or non-renewable? You've got a good memory or remember from the very beginning of the lesson. And what about wood? Is it renewable or non-renewable? 2 minutes. Okay, should we just finishing off? Okay then, so why are coal, crude oil, natural gas considered non-renewable? Because they take much, much longer to form than we use them. If you've put can't easily be replaced, that's good, that's fine. So nuclear fuel. It's non-renewable, it needs to be mined out of the ground and it can't easily be replaced. There's enough left for a few hundred years probably. So wood, it's renewable because as long as you're replanting trees at least the same rate as you cut them down, we can easily replace them. When we use plants as an energy resource, we call it biomass, and we'll look more at renewable energy resources in a later lesson. So if you complete the Google quiz now, this will be automatically marked and you'll get your marks back and see how you've got on. If you want to do an extra summary, then just pause the video. I've got a summary on here, some information about non-renewable energy, how coal was formed, and also petrol and natural gas. So pause the video, make a note if you need to. So thanks for working on this. I'll see you next time for another video on energy.